In today's video, we're going to be walking through a couple of examples using Postman to query open web APIs, showing how they're used in Postman and why you might want to use Postman for that type of work, followed by some examples of how we could accomplish the same thing using Python. Now before we get started, I wanted to give just a little bit of background on why I'm doing this and what my intent is here. So I primarily work in networking, and all the fun stuff over the past couple of years has been all the different networking vendors trying to get different engineers into network automation. So I've attended a couple of different presentations on different technologies from different vendors, and I seem to see at least one pattern that seems to be present in my area. And that pattern is we kind of show, hey, we have this product. It has open APIs, which is cool because everyone likes open APIs now. And we can do cool stuff with that by making this device all programmable and, automated. And then most of those demos and overviews and, product intros tend to end on, let's bring up Postman, let's show a couple of API calls, and then say, hey, isn't this cool, and move on. Now, my experience talking to some engineers in the room is that some people understand, hey, yeah, I get that this is the future, but I don't understand why I'm being told that Postman is the new CLI and that I'm going to be using this for device configuration in the future. Why do I need this bulky graphical user interface to create a new sub-interface on a network device when it takes me 2 seconds on a command line? And the answer I usually give to that is Postman is just one different tool that you can use to test out and play with device APIs. But really, once you want to get into the true power of doing automation and bulk configurations and that type of stuff, you're usually probably not going to be doing a lot of that in Postman. You'd pick up something like Ansible or Python or some other utility. So that gave me the idea a couple of months back to write out a quick blog post where I went through a couple of quick Postman API calls, showed how we do them, some of the basics, and then translating that over to how we could use that in a Python script, not only just doing the exact same work as we were doing in Postman, but also adding on to that a little bit to show where Python gets more flexible. So after a couple of months, it seems like that blog post has gotten a bit more traffic than I had originally anticipated. So I figured it was about time to sit down and record a video just as a, companion medium in case there's anyone that prefers this type of format. Now that I've gotten that all out of the way, let's go ahead and jump into the examples and demo. So first thing, I'm going to go ahead and use this website called jsonplaceholder.typecode.com. This website offers a free online hosted web API that we can query using Postman or Python, and it's going to return a lot of dummy data in JSON format, which is super easy to parse and deal with. So if we go ahead and scroll down just a little bit, we'll look at some of the different endpoints that they have. So under resources, we see that they have a /posts, comments, albums, photos, to-do, and users. And in this example, we're going to go ahead and focus on the users section. So let's go ahead and open up this in a new tab and take a look at what it looks like. So on this REST API endpoint, which is jsonplaceholder.typecode.com/users, we have a list of 10 different users. Each one looks like it has a user ID, the user's name, username, email address, physical address, and some other contact information. So as a human, our first thought might be, okay, hey, this list is only 10 users. Everything's got nice and clean labels. It's easy enough for me to just look through here and say, hey, what is the physical address of Irvin? And I can see he's user ID 2. His address is Victor Plains, Suite 879. And we can get that information very quickly without having to worry about, why do I need to write some automation to parse through this and, find that information for me? It's easy enough for me to just look at it. And that makes sense. This data set is only 10 users, and it's something that we see on our screen, but maybe this isn't something that we have direct access to, or maybe it is a user list that's hundreds or tens of thousands of users long, and we needed to find exactly one person, and we only have one piece of information, like their first name, last name, username, or their email address. And that's where we'd end up looking at something like automation using Python or Postman to be able to work through that data set a little bit more quickly and pull out exactly what we need. So now that we've reviewed real quick the data that we're working with, let's go ahead and take this over to Postman and get started with just figuring out the basics of querying this API. So jumping over to Postman, we're going to start off with this blank API request. To get started with Postman, this is not going to be an all-inclusive deep dive into all of the features and functions and things that Postman can do. We're just going to show off the bare minimum of what we need to do to be able to query a web API. So the first thing we need to do is we see our different web types of requests. Right now, by default, it is set to a GET request. Some of the common request types that you'll use often is GET, which is going to be used to query an API and pull data from it. We'll also see post and put, which are usually going to be used for creating a new resource within the API. So let's say we had that user data set and we wanted to create a new user. We could use post or put to be able to assemble that data locally for the user. So we generate its username, first name, last name, email address, and all that stuff, build that into a JSON data payload, and then use one of those web requests to send it to the user database and create the new user. Now, whether or not you use post or put for that usually is going to depend on the web API. So you'll want to review the documentation of whatever you're looking at. There is a little bit of a difference between how those two operate. We won't get into that in this video, but it is just something you want to be aware of, that some web services and APIs do use those a little bit interchangeably. The other typical request type that we might see sometimes is delete. Now, delete does exactly what you would think it would do, which is, in which case, let's say we have a user that leaves our environment and we need to remove them from our user database. We would usually send an API request using the delete function. And normally when we do that, we're going to have to supply some sort of identifier that allows the API to know which user that we are actually deleting. And in the case of the data that we're dealing with, more than likely we're going to supply a user ID number, since that's going to be unique to a single user in that delete request to make sure that that's the user that ends up getting purged from the database. All right, so by default, this is going to start off as a GET request, which is what we need to do since we just want to query the API. So we'll go ahead and set that. In this text box where we're going to enter our API URL, we're going to go ahead and enter in the JSON placeholder.typecode.com. Now, before we send this request, I just wanted to call out, just below our text box, we see tabs for query parameters, authorization, headers, and body, along with a couple of other things. So if we wanted to get into sending additional data with our HTTP request, we can click on one of those to add additional configuration values. But for this basic request, we just want to go ahead and request a list of all of the users in the database, which we know to be 10. And so if we go over to the right side here, all we have to do is go ahead and click send. Okay, and pretty quickly we get our response back from the web server. And so on the right side real quick, before we dive into the data, we can see that we got a 200 OK as our return status, and it took about 362 milliseconds for us to respond, and we can see the size of the data that was returned to us. And so if we go ahead and scroll through here real quick, we're seeing the exact same list of users that we were seeing on the test website, which is what we'd expect. Okay, now back to the example of what if we had a list of 10,000 users and we needed to pull out exactly one person where maybe we only knew their username. Now, one way we can do that is just by using a query parameter within the HTTP request. So if we go back over to the JSON placeholder website real quick and scroll down, we can see under the routes section that we do support a couple of different methods of pulling out an individual user or item out of the JSON list. So if we looked at the list of users again, so let's say out of this entire user list, we were looking for the user with username Delphine, and that's going to be user ID 9 that's selected here. So let's go ahead and go back over to Postman and see one way that we could do this. So one way would be directly in the query parameters, we can do a key for username, and our value, we're going to go ahead and put in Delphine. And you can see that it auto updates the URL up here with the question mark, which indicates that we're going to be using a query parameter. And again, our key value is username, and we're looking for the value of Delphine. So now if we go ahead and send this request, within a couple of seconds, we get our JSON data response back to us. And in fact, it only has the data for user ID 9, getting that data just for that single individual user in our database. Okay, so this is about where we're going to wrap up with the Postman section of this. So we can see pretty quickly here that Postman is really helpful for testing out a new API, getting to understand what query parameters we're looking for, how the API functions. We can even see what the data that it returns looks like and what formats and key value pairs that we need. And so this is where Postman is really good for, is testing, playing around with, validating what the data looks like. And sometimes it's super great if you're writing a Python script and you're not getting the data back in the format you want, or the API call is not functioning correctly. Opening up Postman real quick and just getting an interactive experience with an API can sometimes really help that. So in the context of network automation, we could use Postman to do something like query a network device for all of the ports and port status on the device. And we'd have to be able to go out to each individual device, call the API, and either get an entire list back or potentially query by each port ID or port number or port name. But one way we'd be able to do this a little bit easier is by using Python. So now that we've shown very quickly how to use Postman to be able to query a REST API, let's go ahead and jump over to Python where we're going to take a look at how to execute these exact same requests and maybe make them a little bit more dynamic. Okay, so right now I have VS Code open. The first thing that we're going to need to do is install the requests module. Requests is just a Python module that allows us to very quickly and easily make HTTP requests. While there are a number of different modules out there that do the same thing, requests seems to be one of the more popular ones, so that's what we'll use here. So first we'll install that with pip using pip install requests. Okay, and that installs pretty quickly. So let's go ahead and start writing our script. The first thing that we'll go ahead and do is import the requests module so that we can use it in our script. Next, we'll define a variable called URL, and we'll use that to store the REST API endpoint that we're trying to call. After that, we'll make our GET request using the requests.get and supplying our URL variable. Whatever data that we get back from that HTTP request, we'll store in the response variable. And then last but not least, we'll just go ahead and print that out as plain text using response.text. We can also do things like check what our HTTP status code is if we did response.status_code, but we know that this is going to work, so let's just go ahead and print out just the raw text as it is. Now that we've got the script set up, let's just go ahead and run this. And if I expand this, pretty quickly we see that we get our list of all of our users again. And as we scroll up, we can see user number 9 is Glenna, who we were using as an example before. All right, so in our Postman example, after we queried the entire list of all of the users, we went back and modified our request to query for exactly one user based on username. In Python, we're going to do that exact same thing, but let's modify that a little bit to make it more dynamic and something that we could embed in a script that would be usable by more people. And so the first thing that we're going to do is we're going to go ahead and print out some text that just states search by username. Next, we'll use the input function to prompt the user to enter in whatever username that they want to use, and we'll assign that to the user variable. After we have that username, instead of just using the static URL, we'll create a new variable called query URL, and that is going to be the existing base URL plus a string that includes the question mark to indicate a query, the username key value, as well as the username that is supplied to us by the user. After we have that information, we'll go ahead and make that same HTTP GET request using the new query URL. We'll tie that back to our response and again print out our response.text. So let's go ahead and run this. And sure enough, we'll see it says search by username and we're given a prompt. So we'll go ahead and type in Delphine, and pretty quickly we get returned that exact same JSON data output of just that user ID's information. Now, for example, let's say we made a user or network port database that we were supplying to our help desk. Instead of having them go into Postman and manually query out information out of a data set, we could write them a script like this where perhaps instead of using user IDs, we provide a script to our help desk that says, hey, search by the switch name and port ID, and we'll dump out the current configuration and state to the help desk person so that they can quickly get a view as to whether that port is up, down, error disabled, or something like that. So now you might be thinking, hey, this JSON data is still pretty readable, but what if I'm providing this to someone who doesn't look at this stuff regularly and has a harder time parsing through it? Or maybe I want to build a script that is available to someone else who doesn't deal with this type of thing regularly. Can we sort through this data and just output individual pieces of it and format it nicely? And the answer is yes. So let's go ahead and take our existing script where we're asking someone to provide a user ID, and we're going to modify it so that it just outputs that user ID's phone number and email address so that we can quickly search for the contact information for one specific user. And so before we modify this script, let's go ahead and look at that JSON data one more time. One thing you'll need to notice is that using the data that's been provided to us in JSON, a lot of this translates to native Python objects like lists and dictionaries pretty easily. So anything in this statement right here that is between these two big curly braces, if we use the JSON module, is automatically going to be parsed into a native Python dictionary. And just outside of that, you see the two normal square brackets. Those would be considered a Python list. So technically we have a list here, but there is only one item, and that item is the dictionary that contains all of the user data. That'll come in handy in a minute when we start actually writing out this script. First thing that we will need to do is add an import for that JSON module. We won't have to install this via pip because it is already native to Python. After that, we'll go ahead and get rid of this print statement at the end because we no longer want to just dump out the raw JSON data. Instead, we're going to go ahead and parse this out for our users to make it a little bit easier. So we'll go ahead and start by first taking that response.txt, which contains the JSON data. We'll use JSON to do a load S, which is load string. We're taking a string of JSON text and loading that into a native Python object. Now again, like I mentioned earlier, our list of one user is technically a embedded Python dictionary then that's within a list. So what we'll do is we'll tag a square bracket 0 onto the end of this. That will drop us into the first item in the list, which should just be that user dictionary. And then we'll assign that into the user data variable. After that, we should just be able to call the key value pairs out of the dictionary to assign that data. So for example, real quick, we'll run through. We'll add name, and that'll be equal to the name value out of the user data dictionary that we just created. Similar, we'll do the same thing with email and phone number. Last but not least, we'll use a couple of Python F strings to go ahead and pre-format and autofill. Even though we're searching by username, we're going to use the user's first and last name. So we'll go ahead and say, hey, this user by this name can be reached by one of the two following methods. And we're going to provide both an email address and a phone number that you could reach them at. So again, let's go ahead and save this file and give it a shot. And first we'll get prompted to search by username, and we'll enter Delphine. And once we hit enter, we're pretty quickly returned that JSON data in the background that is then iterated through, formatted, and presented to us just as a simple text that Glenna can be reached at one of the following two methods, and we now have both her email address and phone number provided to us. So now that we've run through some basic examples of how we can query a REST API using Postman, and then used those same examples within Python and made them just a little bit more exciting, I did want to provide one last example that shows a little bit more of this in the context of network automation. So again, as someone who's a network engineer, you might still think, how is this relevant? Why do I care? Why can't I just do all this via the CLI? So for example, I brought up my Meraki dashboard, and you can see that there's a listing of quite a handful of different devices. I only have maybe 10 or 15 devices on my network right now, but let's say that we were a large school or hospital or any other business where we're using Meraki across our entire network. And let's say we work in an environment where either our employees or guests can bring in any device that they want to access the network. And we have an internal application development team that is trying to build out a new application to service users or self-service for guests or something like that. And they're trying to figure out which operating system that they should target first to hit the widest number of people that use it. Now, one way we could do this, obviously, is we could just go into the Meraki dashboard, go ahead and export maybe our entire list of all of our clients, or have someone manually go through this and assemble that list. But I wanted to show this real quickly in the context of like automation and using APIs, how we can take a quick 30 or 40 line Python script and automatically dump out a list of all of our clients in just a couple of seconds. So let's go ahead and jump back over to VS Code. And I have a new script on the screen right now. This is one that I've written already, and we'll just walk through it real quickly. So again, we only need to import two modules here, both the requests module to make HTTP requests, as well as the JSON module to download and format and work with JSON data. Next, we go ahead and set our API URL, and the base URL for Meraki APIs is api.meraki.com/API/v1. Now, we're not just going to be making calls directly to that v1 API. That is going to be the base URL, and then later on we will append URL paths to that to get to the exact API endpoint that we want to query. Next, we do have to supply an HTTP header that contains our Meraki key, and that key is called x Cisco Meraki API key, followed by the actual value of our API key that was generated by our Meraki dashboard. This is just a key that I'm using to test right now, and I'll go ahead and delete it after I finish making this video. Now, I do have all of my Python functions organized in the order that they're going to execute. So the first function that we have is getOrganizationID. So if you've done much with Meraki networking before, all of your network clients connect to network devices, and network devices are organized into a top-level network container, and you can have tons of different networks within an organization. And as an administrator, you can oversee multiple different organizations. So the first thing that we're going to go ahead and do is send a query to our base URL /organizations, because we need to be able to figure out what organization ID we belong to. Based on the Meraki APIs, we wouldn't be able to just send a request to the Meraki API saying, hey, give me a list of all the devices, because we wouldn't know which network or which organization we specifically wanted to query. This script is only example only. In my case, I only have one organization ID. So when we sort through that data, we're only going to go ahead and pick out that first organization, so that bracket 0, and then pull out the ID key value pair out of that JSON data that's responded to us. Once we have that data, we'll go ahead and return the unique organization ID, and that's going to go ahead and be used by the next part of our code. So in the next function, we see that we want to get all of the Meraki networks that are available to us. And in this case, while I only have one Meraki network configured, we are going to go ahead and query the entire list of all Meraki networks and hand back a list of all of those networks. So again, walking through this very quickly, our new query URL is going to be the base URL, so api.meraki.com/api/v1, followed by the organization's keyword, and then the organization ID that we pulled using that first function, then /networks to query the network containers that fall under that organization. So we go ahead and send that GET request, we return all of that data, and then we build a Python list containing all of the unique identifiers for each of the networks that we are managing. I know it seems like a couple of steps here, but once we have that, we can move on to the fun part. And this is getting all of the network clients. So again, we're going to need to supply our organization ID plus our list of Meraki networks that we manage. And we're going to go ahead and start off by initializing a blank Python dictionary called client count. We also want to supply a couple of query parameters to our API call, in which case we're going to assign the variable Q, and we're going to say how many devices per page and what our look back time span is for devices that have connected to our network. And then we'll iterate through every network that we manage, and we'll go ahead and query that /networks, the network ID that we're looking at the moment, followed by the clients to get a dump of all of the Meraki clients that are connected to that network. After that, we'll go ahead and send that. And again, this HTTP request looks a little bit different because we have GET and we're going to send our query URL. We're going to add our API key via the headers. And we're also going to provide our HTTP parameters in there that are currently assigned to that Q variable. After we get all that back, again, we will dump that JSON data into a variable called data, and then we'll burn through every client that's in the list provided to us and try to see if we can add it to our client count dictionary. And so what this try and accept pretty much does is that if we had Android systems already in our list, we'll try to increment that value to +1. And if that value already doesn't exist in our list, then we'll get an exception for a key error because that key does not exist in the dictionary, in which case we go ahead and create that key with a starting value of 1 since we've counted one client in that list. After we're done iterating through all of that, we will go ahead and just print out a report of here's all of the clients that we have by operating system and how many of them. So now that we've run through that, let's go ahead and run this code and see what our output looks like. Okay, and within a couple of seconds, we see that we get our response back, listing out all of the different operating systems. So one thing you might have seen in the Meraki dashboard is a lot of the items that I had in my network right now do show as a device type as other because Meraki doesn't have a built-in definition for what that device is. So we do see 6 devices up front that are listed as a none type, or there wasn't a client operating system provided. Below that, we do see that we have 3 Android devices, 1 Meraki device, 2 Windows 10, and apparently my Nest thermostat comes up as a wireless memory card. But again, if we went back to our example where we had an application development team that was looking to deploy a new app, and we needed to help them to determine which operating system to target first, while the dataset in my home network is a little bit more limited, based on this list, we could go back to them and say, hey, between Android and Windows 10, that's going to make up a majority of the clients. So those would be the 2 operating systems to target first for the app development. Okay, and that wraps up just about everything that I wanted to cover in this video. As always, the example code that I've used today is located on my GitHub, and I will post a link to that in the description of this video. I hope that this was helpful for you, and thank you for watching.